Okay, we have here today a really complicated looking integral from the UNSW Integration Bee 2020 problem 7. We have the integral from minus 7 pi over 4 to 7 pi over 4, 4x cos x over x squared minus sine absolute value x plus cos absolute value x dx. Okay, so we have a really complicated looking integral here, and with everything here I really don't know where to start, but the thing that jumps out is we have symmetric bounds. We're symmetric around the y-axis here. And this makes me think we could use odd or even functions on this. Okay, so we have this property for odd functions over here to the right, that if we have an integral with symmetric bounds, just like we have in this integral, and if f of x is odd, the whole integral is just 0. And we could just look at a really rough graph of not this function, but some function like x cubed looks kind of like this. And because of the symmetry, like if let's say this is a and there's positive area here, well, the area on this side is equal to this and they cancel out. And that's how we come to an integral of 0. So what I'm claiming is we can use this here. If this whole thing, if I call everything, the whole integrand, f of x, and if that's odd, then this whole integral is going to be 0. So the only thing we really need to do is we just need to show that this whole thing is odd, and we'll use our definition of the odd function over here to the right. If we just plug in a minus x into the function, if we can write it as minus f of x, then we can show that the function's odd. So again, calling this whole thing our f of x, we just need to evaluate f of minus x and just plug in. So in the numerator, we're going to have 4 times minus x cosine minus x squared minus sine inside the absolute value of a minus x, and then here another minus x. Then just simplifying this, 4 times minus x I can write as minus 4x. Cosine of minus x, cosine's an even function, so this actually can be written as just cosine of x. Minus x squared is x squared. I can write this as sine absolute value x, and the same thing here. Inside the absolute value, we can write this as just cosine absolute value x. But then from here, all I really need to do is put parentheses around this carefully, and then notice that what we have here, this everything here is f of x, matches this, and we just have a minus up front. So this whole thing, I can write this as minus f of x, but this is the same as this. This is our definition of the odd function. So because this is true, we can use this and show that our integral is just 0. Okay, good problem with odd functions. Thanks everyone for watching. Have a good day.